there's one last topic I'd like to discuss today that's important for Project Zero. Now, something may have popped up in your mind, which is like, why is Java the way it is? Like, why does Java force us to use classes? Why can't there be code that's not in a class? Or why do we have static methods? Like, I get it that it would be strange to instantiate a math object, but it would really be so bad? Like, why do we need this special keyword? It seems to add extra complexity to the language. Well, it turns out that the reason is that it takes choices away from you as a programmer. That is, you cannot write code that's not part of a class. And by taking that control away, you make your life better, right? So fewer choices means fewer ways to do things. And so if you make a method static, you are putting constraint on what is possible. You're saying this method is static. So there's a lot of things it can't do, right? I mean, most importantly, it can't rely on any state of the current object. It can't use instance variables, okay? And so that makes the code easier to reason about and just restricts what you need to think about, because that's really one of our biggest challenges when programming. Now, fewer ways to do things. I mean, fundamentally, what it really boils down to is less complexity. And when we get to week 11 or so, we're going to talk a lot more about complexity of code. But basically, we want to keep our lives as simple as possible. Okay? So these two Java features, forcing you to use classes and allowing you to use static methods, those are a way of constraining the complexity of our code. Even though when you first see these features, they seem a little mysterious. Now, in general, if you are doing an intro programming class, really what it's truly about in my heart, when I think about a good class, it's about managing complexity. And so Project Zero is going to give you a chance to grapple with complexity, right? So that philosophy of trying to manage complexity is really fundamental to 61B's design and how I think about the lectures, the labs, the projects, and so forth. And Project Zero is going to be the first place where you stare complexity in the face in this class and struggle a little. So one of the additional tools that you've already learned in a previous class, but that I really want to drive home as an important thing you should do in Project Zero, is the idea of a helper method. Okay. What's a helper method? It's just a function that does something simple. Using helper methods basically lets you formalize the decomposition of a large problem into several smaller problems, right? It's just you create yourself a little task that you can do, and then you can focus all your attention on that. And so by focusing all your effort on that single task, there's less room to make mistakes. You have a better sense of what's going on. You end up with, ultimately, less complex code. So as an exercise in seeing how helper methods are useful, let me introduce you a problem we're going to do together in this lecture. So let's say we want to write a method called LargerThanFourNeighbors. It takes an array of dogs and it returns a new array that has every dog that is larger than its 4 closest neighbors. So it's 2 neighbors on the left and it's 2 neighbors on the right. So for example, if I give it an array of dogs with size 10, 20, 30, 25, 20, 40, and 10, the 2 dogs which are larger than their 4 neighbors are 30 and 40. So in other words, if I take this and I highlight these are the 4 neighbors of 30, and it's bigger than all of them. And then 40, its 4 neighbors are 25, 20, and 10, and then it doesn't actually have a neighbor over here. So if you go off the end of the array, well, then you don't actually have 4 neighbors, right? So I guess I'll make that more clear. If there are not enough neighbors, i.e. you're at the end of the array, then consider just the neighbors that exist. Okay, right. Okay, and so that gives us the return value would be 30 and 40, or sorry, an array with dogs of size 30 and 40, and again, it's because of this reason. Okay. Now let me make sure that that programming task actually makes sense, and then we'll solve it together. So let's say we want to write this method. If we give a new input, 10, 15, 20, 15, 10, 5, 10, 15, 22, 20, what is the output going to be for LargerThanFourNeighbors? And I have 3 choices for you here. There's no way to submit this, by the way. Just do it and then in your head. Okay. So the correct answer is 20, 22. And that's because 20, its 4 neighbors are 10, 15, 15, 10. It's bigger than all those. And 22, which is bigger than 10, 15, and 20. So now we understand the problem. And so next, let's try and solve it.